So for case 3 of integrating rational fractions, this is applicable if the denominator of the rational fraction contains an irreducible quadratic factor in the form ax squared plus bx plus c. When you say irreducible, it means it's not factorable. And this reducible quadratic factor should not be repeated. So if that's the case, then there is a corresponding partial fraction in this form where a and b are constants to be determined, and 2ax plus b is the derivative of the irreducible quadratic factor. So this is an example. Okay. By the way, make sure that before resolving the fraction into partial fractions, look at the powers. Okay, so the highest power here is 3, while in the denominator it's 2 times 2, so that's of degree 4. Okay, so the degree of the numerator is less than the degree of the denominator, so this is a proper fraction. You can proceed to the resolving process. Okay, making the partial fractions. If ever the fraction is improper, meaning the degree of the numerator is equal or equal to or greater than the degree of the denominators, you need to perform long division first. Okay, get the quotient and the remainder. So the remainder will contain the divisor, and that fraction must be resolved into partial fractions. And then you can proceed to the integration process. Okay, so we have here a linear factor x, which is repeated. So we are going to apply also case number 2 together with case number 3. Okay, x squared minus 4x plus 5 is irreducible. If you're going to factor this out, okay, using the factors of 5 for the second term of the binomials that you're going to multiply and apply FOIL method now to get the product. Okay, so you cannot form the negative 4x for the middle term. Yeah, another, if again you do trial and error methods, you cannot find the linear factors because this is irreducible. So one way to check if the quadratic factor is irreducible is by computing for its discriminant. Okay, solve for b squared minus 4ac. Recall in the quadratic formula. Okay, in the quadratic formula, to solve for the values of the variable, okay, negative b plus minus a square root of b squared minus 4ac all over 2a. So this is the again the quadratic formula. So if ever the radicand, the b squared minus 4ac, the one inside the radical is negative, we get a complex number, right? Or an imaginary number, meaning there's no real values. So meaning the quadratic expression is not factorable because there are no real values for x. Okay, so we can solve for the b squared minus 4ac value, check if it's less than 0 or not. If it's less than 0, then meaning the quadratic expression is not factorable. So the b is the coefficient in the middle term of the quadratic expressions. It's negative 4 raised to the power of 2, then minus 4 times 1 for the coefficient of the x squared term, times 5 for the constant term. So is it equal or is it rather less than 0? So this is 16 minus 20, or that's negative 4. So it's less than 0. So meaning x squared minus 4x plus 5 is not reducible. So we now proceed to the formation of the partial fractions. Okay. So since we have a linear factor x that is being repeated, so there corresponds to partial fractions. First is a over x. Second is b over x squared. Okay. And for the irreducible quadratic factor, so we'll use the next letter. Okay. Instead of a and b here, of course, we can use other letters in the alphabet. So we'll use c and d. So c times the derivative of x squared minus 4x is 2x minus 4, and then plus d, and then all over x squared minus 4x plus 5. Don't forget to put a grouping symbol and then with the dx. So we need to find the values of a, b, c, and d. So there are 4 unknowns. So we need at least 4 equations. Okay. So in solving for the constants, we have two methods. The first is if you assign values of x, solve for the constants, or form system of linear equations so that we can solve for the constants. So we need first to get rid of the denominators by multiplying the fractions no, with x squared and x squared minus 4x plus 5. Okay, so if we're going to multiply, no, so we'll stop with the integration equation first. So proceed to algebra. Okay, so 2x cubed, this fraction, the integrand, okay, to multiply this with the denominator, of course, only the numerator remains. So I will not put na times x squared, then times x squared minus 4x plus 5. Okay, so the fraction, okay, the integrand, okay, multiplied by the denominator is equal to the numerator. So that's the purpose of multiplying all fractions with the denominator of the given integrand. Okay, so that we can form expressions that are no longer fractions. So if we're going to multiply a over x with x squared and x squared minus 4x plus 5, so only one of the two x's will be cancelled out. So we have one x left, and of course the x squared minus 4x plus 5 plus b, okay, times x, or rather x squared minus 4x plus 5, because the denominator already contains x squared. So what is left is the quadratic factor. And for the next term, so c times 2x minus 4 plus d, okay, divided by the quadratic factor. We multiply that fraction with this, then we have x squared left because the quadratic factor is already cancelled out. Okay, so there is no fraction left. So again, you can do the first method of solving the constants by setting one of these terms to 0 and then solving for at least one of the constants, or use the second method. So for terms containing polynomials of high degrees, then it would be best to use method 2. Okay, so multiply all the factors And then we'll equate the coefficients of the x cubed terms and the x squared terms and the x terms and the constant terms. So meaning 2x cubed has a corresponding x cubed term on the right side of the equation. And because this is an equation, whatever is the coefficient of x cubed here, it should be equal to the coefficient of the x cubed on the right side of the equation. Okay, so first you multiply the factors. So we have x times x squared minus 4x plus 5. That's x cubed minus 4x squared plus 5x. So we have x cubed, x squared, and x terms. And then for the second one, so just copy x squared minus 4x plus 5. So that you won't be writing a lot of stuff. Then you can just factor out the constant instead of distributing it to the terms in the polynomial. Just visually, okay, look at the terms and then equate the coefficients later. So plus c times 2x minus 4 times x squared. So that's c times 2x raised to the power of 3 minus 4x squared. And then for the d times x squared, so dx squared. Okay, so now we equate the coefficients. So for the x cubed terms, the coefficient on the left side of the equation is 2, must be equal to the coefficient of the x cubed terms in the right side of the equation. So for the first term, we have ax cubed. If we multiply these two, the result is ax cubed, right? So meaning the coefficient of x cubed there is a. And then look for other terms, other x cubed terms. So we have c times 2x cubed, so meaning that's 2cx cubed or 2c. So write first the number before the letter and no other x cubed terms left. So this is equation number 1. Then followed by the x squared terms. So on the left side of the equation, we have negative 12. On the right side, we have negative 4x squared times a, so meaning negative 4a for the coefficient. B and x squared, so that's plus b. Then we have minus 4x squared times c, so that's negative 4c. So minus 4c, and we have plus dx squared, so plus d. So this is the second equation containing the 4 unknowns a, b, c, and d. So we have 2 equations so far. So we need 2 more to solve for the 4 unknowns. So the next equation is x. So if ever there are missing terms, like for example, there's no x term on the right side of the equation, meaning the coefficient is 0. Okay? So you need to still write, okay, the coefficients. It's okay if the coefficients no are 0. So 17x. So on the right side, we have 5x times a. So that's 5a. And then we have b times negative 4x. So meaning, or negative 4x times b. So that's minus 4b. And that's for the x term. So this is the third equation. The fourth equation, the last equation, is for the constant terms. So there's negative 15 on the left side. And then on the right side, we have this b times 5, or that's 5b. There's only one unknown here, b. So meaning, using equation number 4, we can solve no for um the first unknown. So equation 1, equation 2, equation 3, equation 4. So from equation 4, again, we can solve for the value of b. So b is negative 15 over 5 or negative 3. So we have 3 unknowns left. So next, look for the simple equations so that we can solve right away for the values of the unknown. So if ever you cannot do substitution step by step, okay, such as this, it would be easier to solve for A since we already have B. So if ever there is a C term or D term, so use the different methods of solving a system of linear equations that you should have learned in your algebra class. So next, using equation 4 or equation 3 rather. So from equation 3, okay, solve for A. So that's 17 equals 5A minus 4B. So 17 equals 5A minus 4 times negative 3. B is negative 3. So that's 17 equals 5A plus 12, or that's 17 minus 12 equals 5A. So that's 5 equals 5A, or A equals 5 over 5, or 1. So since we already have the values of A and B, we can do equation 1 next because we have only two unknowns here. So we have already the value of A, which is 1. So we can solve for the value of C. So from equation 1, solve for C. So that's 2 equals A plus 2C. So if A is 1, so we have 2 minus 1 equals 2C. So we have 1 equals 2C, or C is equal to 1 half. Okay. And then lastly, equation 2, to solve for B, or rather D, from equation 3, or rather 2, solve for D. So it's negative 12 equals negative 4A plus B minus 4C plus D. So it's negative 12 equals negative 4 times 1 plus negative 3 minus 4 times 1 half, and then plus D. That's negative 12 equals negative 4 minus 3 minus 2 plus D, or this is negative 9. Negative 12 plus 9 is negative 3. So D is equal to negative 3. Okay. So we have now the complete constants that we can use for the partial fractions. Okay, so that's A over X. So the given, let's write again the given fraction. So it's 2x cubed. That's 2, negative 12, 17, and negative 15. So minus 12 x squared plus 17x minus 15. and minus 4x plus 5. So a over x, so meaning 1 over x, okay, plus b over x squared. So plus b is negative 3, and then plus c times 2x minus 4 plus d. So that's plus 1 half times 2x minus 4 plus d, or that's plus negative 3 or minus 3, okay, all over x squared minus 4x plus 5 plus 5, okay, and the dx. So we can now proceed to integration. So we can integrate 1 over x dx, and then we can write this second term as minus 3 over x squared dx. So minus the integral of 3 over x squared dx. Okay, now for this one fraction wherein the numerator has two terms. Okay, so we can divide this into two fractions so that we can integrate. No? So if you can see, the denominator is x squared minus 4x plus 5. So the numerator has the derivative of that quadratic factor. So meaning if we let u be equal to the denominator, then there's a du on top. So meaning we can integrate it as du over u. Okay, but there's a constant here, minus 3. So we can have this as a separate fraction and then look for a formula that we can apply, okay, to integrate it. Let's write it first. So separating the two into two other fractions. So we have 1 half, or you can put the constant outside. Okay, and then 2x minus 4, which is again the derivative of x squared minus 4x plus 5 dx. Then minus the integral of 3. Okay, or we can put that here outside, and then dx over x squared minus 4x plus 5, or that's 1 over x squared minus 4x plus 5 dx. So each term can now be integrated. Okay, for the first term, of course, we have a formula for that. Okay, using one of the properties of indefinite integrals. So it's ln of x, of course, plus c, and then power formula for the second term. So this can be expressed as 3x to the power negative 2. So the integral is 3. So you have minus 3x to the power negative 1 over negative 1. Or that's negative 3x to the power negative 1. Or that becomes plus 3x raised to the power negative 1. Or that's 3 over x. Okay. Then for the next one, you have let u be equal to x squared minus 4x plus 5. So du is 2x minus 4. Okay, which is already found on the numerator. So it was 1 half times, okay, the integral of du over u. And then minus 3 times the integral of this. Okay, So do we have a formula for the integral of a quadratic expression in only in the denominator with no other polynomial on top or in the numerator? So if we're going to let u be equal to x squared minus 4x plus 5, so we need to form the du. You cannot form the du if we let u be equal to x squared minus 4x plus 5. Okay, there's no 2x minus 4 in the numerator. So this is a quadratic expression. Okay, we can transform this into a perfect square. So we need to add something, okay, to make it a perfect square trinomial so that we can express it in the as u squared plus or minus a squared, okay, or a squared plus or minus u squared, and use the corresponding integration formula. Okay, so we need to transform this first to integrable form. So to make it into a perfect square trinomial, okay, so you need to divide the middle term by 2. So 4 divided by 2, that's 2. And then you square it. Okay, so meaning we need to add 4 here. So plus 4. So you should not change the value, no, of the fraction or the integrand or any expression. Okay, you need to balance it by subtracting it by 4. So it's as if you're just adding 0. Okay, so for this one, it will now be equal to, so let's just write the other terms here. So this can be written as c over x, and then the result for this third term is ln of u, and u is x squared minus 4x plus 5, so you can write it as ln of x squared minus 4x plus 5. And for the third one, okay, so it's now, so let me just write the new form here on the side. So it's x minus 2 quantity squared. If you factor out x squared minus 4x plus 4, or rather if you are going to factor, no, x squared minus 4x plus 4, it's the square of x minus 2. No, a special product. Minus 4. So meaning it's in the form a squared, or rather u squared, no, minus a squared. It's in the form u squared minus a squared. And the integral of du over u squared minus a squared. So u is x minus 2. So if you are going to solve for the du, it's just equal to dx. So meaning it's in the form, no, du over u squared minus a squared. And the integral is 1 over a times arctangent of u over a plus c. So meaning it's minus 3 times, okay, 1 over a. A is equal to, okay, a is, eh, okay, sorry. So there's still a 5. So I forgot to write the 5. So there must be a 5 here. No, it's x squared minus 4x plus 5. So I did not return the last term, or write the last term here. There should be a 5 here. So x squared minus 4x plus 4 is the square of x squared, or square of x minus 2. So for negative 4 plus 5, so that's positive 1. So this should be equal to positive 1. plus 1. So meaning it's u squared plus a squared. So that's why it should be arctangent for its integral. Okay. So u is x minus 2 and a is 1. So again, it's 1 over a arctangent. Okay. So meaning 1 over 1 arctangent of u over a. So that's x minus 2 over 1. Okay. Then the plus c. Or simplify everything. So ln of x plus 3 over x plus 1 half ln of x squared minus 4x plus 5 minus 3 arctangent of x minus 2 plus c. Okay, so this is the final answer. So this is the integral of that given fraction with the dx. Right. Okay, so this is case number 2, or rather case number 3 of rational fractions integration.